Welcome to The Explainer. Today, we're going to dive into a hidden dimension of math. We're talking about a kind of number that's behind everything from electrical engineering to quantum physics.
You know, let's kick things off with a quote from the brilliant Johann von Neumann. He said, "In mathematics, you don't understand things, you just get used to them." And that is the perfect mindset for what we're talking about today, because we're about to meet a type of number that feels, well, a little weird at first. But trust me, once you get used to it, it's incredibly powerful. So our journey starts where a lot of great math stories do, with a mystery. A really simple-looking problem that, believe it or not, is totally impossible to solve with the numbers we use every single day. Okay, take a look at this equation. If you try to solve for x, right, you just move the 1 over and you get x squared equals -1. But hang on a second. Think about it. What number, when you multiply it by itself, gives you a negative? A positive times a positive? That's positive. And a negative times a negative? Well, that's also positive. So what gives?
Right, exactly. With the numbers that we're all used to, the ones on the good old number line, we call them real numbers. There's just no answer. I mean, take 2, square it, you get 4. Take -2, square it, you still get 4. There's just no way to get a negative result. For hundreds of years, this was basically a dead end in mathematics. So this dead end forced mathematicians to ask a really bold question. What if the problem wasn't the equation? What if the problem was our numbers? What if our number system was just incomplete? What if we needed to invent a new kind of number to solve this?
And that's exactly what they did. The answer wasn't to find some dusty, forgotten number. It was to invent one. And this was, a huge leap of imagination. It basically blew the doors wide open to a whole new world of math. So what did they do? It was actually kind of simple and brilliant. They just defined a solution into existence. They created a new number. They called it I for imaginary. And its entire job, its whole purpose in life, is to be the number that when squared gives you -1. So I is just defined as the square root of -1. Boom. Problem solved.
But here's the thing, inventing I wasn't just a patch for one little equation. It opened up the floodgates. It gave us a whole new family of numbers called complex numbers. And every single complex number has 2 parts to it. You've got the real part, that's A, the kind of number we already know, and then you've got the imaginary part, B, which is the part that gets multiplied by our new number I. And this is the key takeaway, really. A regular old real number, it's just one piece of info. It's just a single spot on a line. But a complex number, well, it's holding 2 pieces of information at once. It's got its real part and its imaginary part. And because of that, a simple one-dimensional line just isn't going to cut it when we want to visualize these things. Okay, so if a one-dimensional line isn't enough space, how in the world do we visualize these things? Well, it's simple. We need to add another dimension.
Right. Remember that number line from elementary school? It goes left and right, positive and negative. That's it, one dimension. There's just not enough room on there for a number that has 2 separate parts.
So here's what we do. We take that familiar horizontal number line, we'll call that the real axis now. And then, right through the 0, we draw a second number line, but this one goes straight up and down. That is our new imaginary axis. And now, plotting these numbers is super easy. A complex number is no longer just some abstract thing. It's a point on a map. The real part tells you how far to go left or right. The imaginary part tells you how far to go up or down. So a number like, say, 3 plus 4i, that's just 3 steps to the right and 4 steps up. It's a real, physical location at the point 3, 4.
Okay, now for the really cool part. Let's get into our final section. Because having this second dimension, it gives these numbers a kind of geometric superpower, something that real numbers just can't do.
All right, this is the big reveal, the payoff. Watch what happens. If you take any complex number on this plane, any point at all, and you multiply it by I, something incredible happens. The number rotates, a perfect 90-degree turn counterclockwise around the center. That's what I does. Multiplying by I is rotation. And this isn't just some neat party trick. This rotation property is absolutely fundamental. It's the reason complex numbers are so crucial in physics, in engineering, in processing signals, basically anywhere you're dealing with waves or things that rotate. So, that name, imaginary,
it's kind of a bad name because the effects of these numbers are very, very real. So let's recap. We started with a problem that seemed impossible. What's the square root of -1? We solved it by just inventing a number, I. And that single act of imagination didn't just solve a puzzle. It unlocked a whole hidden second dimension to math, a place where numbers don't just have value, they have a location, and they can move.
And that brings us to our final thought. If inventing just one new number could unlock so much, it really makes you wonder, doesn't it? What other huge problems that we face today are just waiting for one little act of imagination to solve them?